soon as information starts. Okay, we are cool. Okay, guys, welcome to another session of Porto.DATA Community. This is the session number 73, and I'm glad to have with me my good friend David Barberin. David, thanks a lot for being in here, okay, and thanks for your availability to provide this session to us, okay. Now, just a couple of things David will present. If you have any questions during the session, please raise your hands on Teams or just chat something on the chat window. Just write something on chat window, and we will basically answer your questions, or David will answer your questions if he is able to do so. If you are Portuguese and if you basically have any kind of problem to raise your questions in English, you can do it in Portuguese. I will translate for to be recorded, and David will answer as well in English. Okay, guys. David, once again, man, thanks a lot for your time. Okay, the stage is all yours. Go ahead, my friend.
Okay, thank you. So here we go. Welcome, guys and ladies, to this session. Porto data number 73, as said previously by Ivan. So thank you for having me today. It's always a pleasure to speak for Portuguese SQL community. So today we will talk about storage performance for SQL Server in virtualized environment. So it will be a good opportunity to share some feedback from my own experience with some figures and metrics, right? If I have time, I hope so. Let me get the focus. Okay, so just a quick introduction of myself. I'm David Barberin. I'm a French guy. I'm working for a Swiss company, Migros Online, basically in a retail online area. So I'm working in a full DevOps world to now. So yeah, I'm a data platform enthusiast, and I like to share my experience through events like Porto.DATA or blog post. If you want to connect to me, feel free to do it, and it will be a pleasure to discuss with you. The agenda is pretty simple for this session. So first topic is maybe a good reminder of SQL Server I/O patterns, and how it basically we will see how SQL Server deals with I/O regarding your workload, and which query you are performing through the SQL Server runtime. And the second part will be dedicated for storage virtualization and performance configuration. In my context, it's always hard to talk about generic stuff because you have some storage specific configuration, context specific configuration, but I will try to provide some guidance I follow myself for virtualizing SQL Server and to provide storage performance for that. So let's start with SQL Server I/O patterns. So when you are entering to the SQL Server world and you are dealing with I/O and storage performance, you have to be aware of a different, let's say, concepts around SQL Server. We will talk about pages, extend, file groups. We will hear about a lot of about synchronous I/O, asynchronous I/O completion ports, even if it's not directly related to I/O in terms from a storage perspective, but for network. Instant file initialization, what is that? And something you probably heard about SQL Server that is using extensively scatter gather APIs from Windows. So let's start with the page. For SQL Server, the page is the basic unit of storage for SQL Server. This is where you are storing your raw at least if you are using a traditional storage for SQL Server, we will not introduce the column store storage in this session. So the page will have different information in the header section. You will have the payload with your data row and the offset to identify the position of your row within the page. Okay, so basically 8K kilobyte for storing all this stuff within a page. SQL Server will organize will manage the storage in a more efficient way by using extent. It's a contiguous group of pages in SQL Server. So you have different sort of extent, mixed extent, uniform extent. Since SQL Server 2016, if I'm correct, uniform extent is by default. It means that you will use all the pages for one. We will dedicate all the pages for one object in this case, unlike mixed extent where you can share pages within the extent with different objects. But it doesn't matter in this for the storage from a storage perspective. These extents are stored in a file, physically stored in a file in SQL Server, and SQL Server will organize logically file within file group. And regarding how you will configure your setup, including file group, SQL Server will behave differently. So we will see that in a couple of minutes in the next slide. But let's start with some concept with SQL Server I/O pattern, synchronous I/O. Synchronous I/O is probably the most simple one. It means that basically the calling thread will wait until the I/O operation finish. Okay, so your thread will wait, and it will continue to process the work afterwards. This is not a big issue if it concerns fast I/O operation. It's suitable for fast I/O operation. Because it will avoid the overhead of processing I/O asynchronously. Okay, because for asynchronous I/O, we'll talk about it in the next slide. You will have to deal with other structures in memory, and you will have also to deal with what we call thread synchronization. Asynchronous I/O, mostly used by SQL Server from a storage perspective. In this case, the calling thread keeps working when I/O operation is performing. Okay, what is the goal of that? The goal is to maximize the CPU resource utilization, because in this case your CPU is not idle, is not waiting on your I/O operation. It can do job until the I/O is performing on the kernel side, and it will also maximize the disk throughput. Just remember, with hard disk, when you will have to write to the disk, from a performance perspective, it is better to have sequential I/O and large I/O to write that random I/O where seek and latency and rotational stuff is coming to the game. Okay. But as said previously, the asynchronous I/O will come with additional structures, overlapped structures, because in Windows world, in fact, we are talking about overlapped I/O when we talk about asynchronous I/O, and in Linux world, we are talking about non-blocked I/O. So this overlap structures is just here to signal to the thread the status of your IO if your IO is completed. Okay. But I said previously, the main problem with asynchronous IO is to deal with thread synchronization, because you will have, in this case, different concurrent access on maybe the same structures, same parameters, same values in memory. You have to protect the structure between concurrent access to avoid what we call the race condition. The scatter gather API is probably the most interesting one from my point of view, because in terms of performance, because it will improve a lot IO operation on disk. Either we are talking about reading or writing data into disk. In fact, this API was started to be used by SQL Server 6.5, if I remember correctly, and the goal of that. But maybe we can talk about without using scatter gather. If we without this kind of API, we have to allocate separate thread to deal with each block to write onto disk. With this kind of API, you just have to deal with one IO, for example, to write all this non-contiguous memory space within the buffer into disk. So you save resource consumption and you maximize the disk throughput in this case. This is the goal of this API, and mainly used by SQL Server with asynchronous IO in this case. Obviously, there are some prerequisites for that. You have to use non-cache IO. This is non-cache IO mainly used by SQL Server with asynchronous IO. You will have to use asynchronous IO, and because you don't want to use system cache and all the cache within the IO path, you have to be aligned. You have to align your memory structure with the sector disk size in this case, but. Another interesting mechanism used by SQL Server is instant file initialization. So to cut the story short, when you want to allocate space on Windows, you want to reserve space on disk, you have to set the end of file from API perspective, and to reserve the space, you have to write 0 within the file. This mechanism is pretty efficient if you are using sequential write, because you will reserve the sequentially from the begin to the end of the file, and you will write the a small section of what you want to where you want to write. But with SQL Server, allocation is done randomly, so it means that you will have to allocate all the space within the file when you allocate this. When you allocate the space, when you create a file, when you have auto growth, this kind of stuff. So it will have a direct impact on transaction performance, for instance. With instant file initialization, the process is different. You will set the end of the file, but you will just validate the data length of your. In other words, you will reserve logically the space within the file. So basically, you will just keep the zeroing file. So if you don't have any, so you have to provide to SQL Server Service Account some privileges, the perform volume maintenance task for that, and it also have some concern in terms of security. So if you have strong security concern or strong security rules, in this case, maybe you will not be able to use it because you are not writing 0. You are not writing 0 in file. Potentially, you can see previous data in data file in this case. So in terms of security, is probably not what you want to achieve, because you will not, in fact, remove data from the disk. Just to summarize, in terms of I/O patterns, SQL Server is using mostly non-buffered and asynchronous I/O. For reading, writing data page, the goal, just to recap, is to maximizing CPU utilization. We don't want to getting a worker waiting for an I/O operation for a CPU, and we also want to maximize the disk I/O throughput. This is the two main interest of using this kind of patterns. So because by design SQL Server is using non-buffered and asynchronous I/O, it will extensively use QDEF in your I/O path. And this is something you have to take care of when you deal with SQL Server and when you are monitoring the QDEF. In fact, the most important is not so the number of I/O in the QDEF. It's more the time spent to the QDEF before processing to the storage in this case. Okay, so you can have a good throughput with a lot of IOs. So just and from my perspective, monitoring the number of IO in the QDEF is not so relevant in this case, but latency is probably more important according to what you are doing on SQL Server with IO random and sequential. So far we talk about SQL Server IO pattern with how they use asynchronous I/O, synchronous I/O, scatter gather API, etc. So now we will talk about SQL Server I/O size. So the first things to keep in mind is that the allocation unit size, the famous 64K used to format your NTFS volume, is different from the SQL Server I/O size used by SQL Server. Okay, this is something important to keep in mind. The SQL Server I/O size is variable and depends mainly on the operation done by the storage engine. I put some example here. This example come from Pure Storage blog and Microsoft blog, so you can find easily this kind of information on the internet today. But what you can see here, that is surprisingly random operation, surprisingly or not, random operation is not the rule of thumb for SQL Server. It's just used by indexing operation. I put 8K to 64K because in terms of IO operation, SQL Server is doing 8K operation because it will deal with the pages. Okay, he has to read all the pages to read your data, but because it uses extent for managing efficiently the storage, you will see a lot of 64K size when with some IO operation. Sub-IO operation with indexing, for instance. For the transaction log file, you can see here that the interval is pretty is interesting because you have a 500 12 bytes to 64K bytes. 64K bytes is sequential when, for instance, because the buffer, the transaction log buffer is full and needs to be flushed to disk. So the operation will be sequential and with a size of 64K kilobytes in this case. So you can see a lot of operation done sequentially with varying size from 8 kilobyte to 1 megabyte or more, 8 megabyte for column store. If we talk about checkpoint, lazy writer, eager writer, they are all asynchronous process. The famous read-ahead mechanism scan when you are reading entirely a structure or partially a structure. So SQL Server will use optimized mechanism to benefit from disk throughput in this case, and you also have the same mechanism for some buckload operation, backup, restore, file initialization. So you can see here that SQL Server is using the IO size is not fixed; it's a variable from a storage perspective. Quick word about file groups and file. When you create a database and you put some database file, you are organizing your file within a file group, etc. So it will in fact behave on how SQL Server will achieve I/O from a storage perspective. Let's say that you will want to use one file per file group. On D drive and let's say M drive, you have one file group for one user database on D drive, and for the same database, you have another file group with a file. When you when you will put some table to one file group and other table to another to other file group. So in this case, if you perform a join of this table, SQL Server will probably will use in parallel your storage. So it means that your join operation will be parallelized by SQL Server. So if you are doing a large scan, so you will have two parallelized IO operation at the same time, probably in sequential manner with read ahead in this case. So if you are using the same mechanism that is used by TameDB so far, so it meaning that you are putting several files within a file group, SQL Server will change the algorithm and its behavior for doing I/O. In this case, you will not parallelize I/O, but you will use round robin and proportional fill algorithm, meaning that you will create a kind of storm of random I/O for TameDB. So in this case, you will probably have to configure your storage for random I/O, not for the previous case with sequential I/O in this case. Okay, so depending of your configuration, SQL Server will behave differently on I/O for the I/O. For you, fortunately, SQL Server, the SQL Server team is provide best practices guidelines for configuring the storage layer for SQL Server, at least from Windows operating system perspective for both Windows and Linux today. I put here the most relevant. You have the partition alignment, but since Windows 2008 is not a big matter unless you are migrating your volume from Windows 2000 or for previous versions at 2008. You have to format correctly your NTFS volume with 64 KB. It's just a way to optimize the NTFS allocation. Is not I/O. Is not a matter of I/O in this case. The number of TMDB files, the number of data file and log file per user database. But here it's difficult to provide a generic or a rule of thumb for all context because the context matters. It depends of your storage configuration, your workload, but what we can say is that as best practices, you can at least keep storage activity on dedicated disk for SQL Server. And if you have to consider other stuff if you are dealing with virtualized and shareable environment. So the second part of this session. Obviously, instant file initialization and anti-terrorist exclusion is something important to consider if you are dealing with performance. So before jumping to the virtualization part, let's just define what performance means for storage. We can define and we can measure performance for storage with three metrics. The IO per second, okay, basically it measures how many IO requests that can be satisfied by the disk IO path in a second. You have the throughput or megabyte per second. So basically how much data that can be pumped by your disk IO path in this case. So this kind of pressure it can sustain in this case, and latency. Latency also known as the IO response time that will basically measure how fast an IO request can be proceed by your disk IO subsystem. Okay, so this is the three metrics we are dealing with when we talk about performance storage. So storage virtualization. So in this, when we probably most of you are dealing with virtualizations today, it's pretty common to have this kind of environment, I would say, except for some specific context. But as for many of customers I did with in the past, when we are talking about storage virtualization, we are talking about enterprise class storage behind the scene. It's a very it's not often to see virtualization with direct access storage in this case, but more enterprise class storage that is more suitable for this kind of scenario where you have to deal with a lot of virtual machines, a lot of servers with the storage behind the scene. So but you have to, for when you configuring your enterprise class storage or your SAN storage network, it's important to remember that more ops you have in your topology, the more latency you will see. Okay, so for instance, for this on the slide, you will have a lot of ops between the SQL Server VM and the storage hallway. You will go through the virtualization layer. You will have to go through the fabric interconnect part with HBA card, with switch, with fabric interconnect and so forth. And at the end, you will reach the storage array with cache controllers, processors, and disk at the end. Okay. Obviously, the ideal scenario is to have a flat fabric here with one hub, but we are far away when we are talking about storage virtualization and virtualization environment. So just a few words for the fabric stuff. So it is not supposed, I guess, for a database administrator to deal with this kind of stuff. At least you will not be involved for all the stuff doing in this case. But I think knowing all your IO path is a good advantage for database administrators to understand how performance can be measured, how performance measure, and where problem, how you can identify the problem. So just to set the context is my own context. We are using pure storage array in this case, in active and stretch cluster for sharing storage between two sites, and you also have local storage with site 1, site 2. If we are dealing with application like SQL Server and availability groups, where replication is managed by SQL Server. So you just have to have local storage, not storage in this case. We are using fiber channel in this case because what is interesting with the micro latency storage is to use fiber channel is a good way to achieve sub-millisecond latency between the server and the storage. So we also are using CS blade hardware with Cisco Fabric Interconnect, etc. So okay, so I don't want to go into detail of that, but what you have to know in this area is to identify which component or where you have to pay attention when we talk about performance. The first one is to identify if you have clean path. The path is a path between the storage, here the fabric, the fiber channel, Cisco, and the fabric interconnect. So if you, for instance, with the previous setup, we have some CRC issues that lead to have unpredictable high latency spike from SQL Server, and we get struggle to identify which how the problem was in the so at the end, we just took a look at the fabric interconnect topology, and we identify a lot of CRC issue for one of the components that was the root cause of our problem. So this is basically the most important one from our perspective. The second one is to ensure in your fabric interconnect topology that you have a consistent poor connection speed. So it's often customers are not aware of raw switch port that is hard coded, hard fixed to for let's say for this one to 4 gigabytes. Obviously, for in terms from IO path perspective, the performance of your IO path is the performance of the weakest component in your topology. So this is something you have to identify. If you expect, for instance, to have, in my context, to have 32 gigabytes of throughput, meaning 4 gigabytes, 4 meg. Gigabyte, pardon, and not gigabits, for gigabyte for in terms of throughput. If you are dealing with 4 gigabits of links, obviously you will not achieve to reach 4 gigabytes of throughput in terms of performance. So you have to identify all your component where, for my context, MDS Cisco specifications, the Cisco Fabric Interconnect, and you also have the IO module from the blade. So something interesting to look at, but once again, probably not something achieved by all DBA. It is more a storage admin concern here. If we IO path and performance means, so you have to deal with all components in your IO path. You have the IO ops, but you also have your IO component, your storage component in different layers. We talk about the fabric interconnect, but you also have the array. But the array, I don't already speak about the array because it is vendor specific and it depends of your model, in fact. I will give a focus on the virtual side in this case. So the first thing that to bear in mind is when you are doing storage virtualization, you will face probably to the blender effect. The blender effect, what is a blender effect? So in fact, if you have a lot of adoption of virtualization technology today, even for SQL Server or other application. Okay, it means that you will consolidate your server workload in a different host machine. This kind of architecture will have a profound impact of the efficiency of your storage because you will have to deal with additional challenges in terms of storage. It means you will multiplex distinct I/O workload into a single pipe. Okay, so in this case, it will cause a sharp increase of random I/O at the end. So this is basically what the idea of this slide. Because if you are so far we talk about SQL Server with random I/O, with sequential I/O, etc. But when you are consolidating SQL Server, at the end, if you don't care about it, of your storage virtualization design, you will end with random I/O in the most of cases. So this is something you have to bear in mind when you are virtualizing SQL Server and you are sharing your environment with other SQL Server instances or other applications. Just some words about the components within the storage virtualization, but from virtualization perspective. I will talk mainly about VMwares because I'm working with VMware in my company, but I suppose there are some similarities with Hyper-V, but okay, I'm not aware of that. So let's just focus on VMware side for that. So as you can see here, for virtualization, you have different layers. You have to take care when it comes performance, because let's start with maybe some components in this stack. So the first things you have to take care is about SKZ adapter types you will use with SQL Server. The default one is LSI Logic SAS. Okay, it comes with many of installation, but you can use what we call today the Power Virtual SKZ adapter. This adapter is more suitable for high intensive workload like SQL Server. If you have high intensive workload, you have to define it. But in this case, obviously, you have to meet some prerequisites like hardware or version, and you have to install the VMware tools on the machine for that. But the Power Virtual driver provide interesting stuff like lower CPU cost for IOs and lower high latency. This is the first interesting advantage. The second advantage by using Power Virtual SKZ adapter is you will benefit from QDEF value configurable QDEF, sorry, with a value from 64 to 2056. Unlike the LSE Logic SAS with predefined QDEF 32 in this case. Just remember that when we talk about storage virtualization, we will talk a lot about QDEF because SQL Server use extensively asynchronous I/O, and QDEF is an important topic in the storage configuration. So
David,
you have
David, just a question from my side. Does Windows basically deals differently from using, let us say, disks presented directly to the OS rather than Moonpoint, or it behaves exactly the same way?
From my understanding, it doesn't matter if it concerns Moonpoint or drive
or disks or drives
or disk or drives in this case, because behind the scene you will have to deal with devices. Okay,
makes sense.
So this is the first things to keep in mind. So you have to configure on on the Windows side, I will show you afterwards. If you are using parallel virtualized SCSI, if you want to configure or to increase your QDEF, you have to change register key for that. The second aspect of QDEF, it's on the adapter side. You have the device side and the adapter side. So I will just anticipate here. You will directly have the same kind of configuration at the vSphere layer for LUNs and for the HBA cards. HBA cards are cards that connect your host server to the storage, basically. So you have different you have different QDEF configuration for the storage virtualization layer in this case. Okay, so why we needed to take care of this configuration? As I said previously, we wanted to. It is mainly for the funnel effect, because if you have basically QDEF with a low value, and if you are doing a lot of IOs, you will end to fulfill your QDEF and to get direct performance impact of increasing your latency. Okay, this is a direct effect of having a misconfigured QDEF at the storage at the virtualization layer. The second one is the blender effect, but the blender effect, you can mitigate the blender effect. For instance, in this scenario, let's say I use 3 VMDK. So basically, I created one virtual disk for the system, one virtual disk for the data, SQL data, one virtual disk for the SQL log. All virtual disks, in fact, in terms of VMware, are files stored in VMFS file system, a proprietary file system from VMware, and all these files are organized logically within that data store. And data store, even data store has its own QDEF in this case. So it means in this case, if I put all my disk on the same data store, I will just have one QDEF, even if I, for instance, let's say I have per device, meaning I will have 128 per QDEF per devices. Here I will have one QDEF, let's say per 32, and in this case you will suffer from funnel effect. So a good way to mitigate this stuff is to have several different data store for your SQL Server virtual disk in this case. So you will benefit from different QDEF from a data store perspective in this case, and you will have to configure the QDEF at the HBA level in order to handle all this traffic. Okay, so it can be confusing at the beginning, but all the QDEF configuration is important for VMware, from the storage, from the OS layer level to the HBA, meaning the ESX host hardware that you will have to take care of. So something. This is how we can, in my context, we dealt with the different QDEF settings from the Windows operating system level. We just use parallel SCSI adapter. We can have a maximum of 4 adapters with 1 QDEF per adapters. So we set this value, the max QDEF for each QDEF in this case. We use one data store with one data store per disk. In fact, it's not the same configuration than here to benefit from a QDEF at this case. From QDEF per device in this case. And we also have to configure the QDEF at the vSphere levels with the LAN QDEF per pass. That means that you have to set up the maximum value you will have, and we also have to configure. We also had to configure the max QDEF at the HBA card layer. So we had to update the driver of Cisco because we use the ethnic drivers, and the HBA come with its own specific value, default value, if we're regarding the model QLogic, Brocade, Emulex, or Cisco, for instance. So basically, we had 32, and we changed for 124 in this case. And at the end, we have the storage specific configuration, but fortunately with pure storage, we use the protocol endpoint, and each endpoint is able to handle a lot of I/O per protocol endpoint. So yeah, we are comfortable with that. Just a few words about overcommitment. So as I said previously, you are dealing with a shareable environment with maybe a lot of VMs on the same host, and maybe on different hosts that share the data store. So in this case, you have to take care about the overcommitment issue in this case. So let's say you will configure the max outstanding IO per LAN to 32, and you estimate an average number of IO per VM to 16. So in this case, and you have a LAN QDEF to 32 as well. So in this case, it means that from a host perspective, if you are using 16 IO per VM, you will not be able to manage more than 2 VM per host or per data store in this case, unless suffering about overcommitment issue. So we have a lot. So we just tested a lot of configurations. So we estimate a number of 32 IO per VM, active IO, but it's really for us a huge number. So at the end, putting this kind of configuration means that we can have a maximum of 8 VM per host and 32 VM per data store in this case, if we are in this kind of configuration. But for us, it is acceptable to have that. So how we can measure IO path and latencies? Fortunately, with VMware, you have a lot of metrics for that, and each metrics can give you a latency from a different level perspective. If you are on the guest, if you want to measure the latency from the kernel, from the device, just before the storage, or the storage by itself. Okay. And if you wanted to get this kind of metrics, my favorite one is using is ESX stop. I will talk about it just afterwards. Or you can rely on the VMware performance counters. But what I don't like with the performance counter is sample interval is often too big. By default is 30 seconds by default, if I'm correct. Or when you want to test some performance stuff, you want to have an interval lower for that. I don't know how many times I have.
You are good. You are good.
No, good. Okay.
We have more or less 15 minutes. Max.
15. Oh, okay, good. Okay, so What we decide for when we choose to implement pure storage, we did some performance testing campaign. We use both synthetic IOs with the disk speed tool and synthetic workload with HammerDB. For the first one, okay, I think you all of you know what is disk speed tool. The goal of this tool was just for us to calibrate the IO capability of the flash, but it does not represent really our workload. But it also always interesting to know in terms of benchmark how the flash the storage array is behaving. Okay. So we just configure from a SQL Server perspective. We have the same configurations that we have in prod. We didn't want to have a performance testing campaign that is not relevant for us. And obviously, we include all the performance metric for the storage, like including IOPS, throughput, and latency. Maybe something we have to be aware of when you are dealing with a disk speed or this kind of tool and modern storage is a zero removal storage capability of the storage array. It means that if you are writing zero, that disk speed tool is achieved when you initialize the file by default. You are writing zero within the file, basically. The SQL Server, the storage is able to identify this kind of pattern, the zero pattern, and it will simply bypass the disk. You will not write to the disk. You will stay on the controller cache and this kind of stuff. So this is important because just as example, I just performed some tests, and if you if you use disk speed by default, and if you read it's read test performance, you can see here basically that I have more than 200,000 IOs. So interesting performance for that. But if I use a disk speed and I force it to write data randomly into the file, not zero pattern. And if I perform the same test afterward, you can see the performance is definitely not the same because we are reaching the disk. And this kind of capabilities concern a lot of storage. In fact, the sweeper, the HP, the storage, etc. So there are different wording or for these capabilities, but this is why you have to take care of how you will achieve your performance testing with that. For obviously we also use ESX stop command from VMware. It is pretty well documented. So in this case, we just focus on the path, IO path. In this case, on the data store. In this case, so it concerns this one. Okay. So how we can read this kind of let's say the outputs. So the first one is you have to focus on the DQLAN. The DQLAN is your QDEF configuration from HBA perspective in this case. HBA data store HBA perspective. So in this case, we have the correct one. You also have to take care about the active IO in your QDEF. In this case, we have 40 IOs. It's just a snapshot, obviously. And you also have to take care about this column. This column is pretty important because it tells you the number of IOs that are waiting in your QDEF. It means that your QDEF is already full, and the IO in the IO value here represents the number of IOs that are waiting after all the IO in the queue. Okay. On the other side, you have latency metrics with edge from the HBA storage from the storage perspective, okay, from the USX kernel perspective, and from the guest perspective, at least from vSphere level. Okay, so it means that is not so bad here because we are achieving a lot of IOs for a lot of IOs. So the difference between commands and reads here is the commands include also SESE commands. This kind of commands that are not IO but also other operation done by the storage. And as something interesting in this case, if you take a look at what you can see here in terms of latency, so we have a latency, sub-millisecond latency in this case, okay, so because it is in millisecond, so we are in microsecond latency, we achieve microsecond latency, but from the operating system, you can see here that we are achieving we have an average latency of 5 milliseconds. So this is an interesting point because in this case it means that the virtualization at the virtualization layer, you are not viewing what is doing at the operating system layers. You just remember all the stuff you have to configure in the operating system layer with a registry key. So you just have to remind this kind of stuff when you are dealing with latency on Windows side. You have the user and kernel layer, of course, and depending of what you are using from a SQL Server perspective, the latency is viewed at the top of the IO path from the operating system. Okay, and let me. I don't know why. Voilà, okay. And if you are using performance counters, like like I put previously, so the average disk second per read, so basically the latency, you are viewing the latency, but at a different level of the IO path. This is why sometimes you have some differences between SQL Server and Windows Server, because you have all this stuff that is not taking into account for the performance counters. And from my context, you have to deal with what we can see here to the VMware side. The VMware side is doing the latency at this level, and the performance counters is doing the latency at this level. So it means that you will have to identify what is happening in this case. There is an interesting tool for that, the Xperf monitoring tool, Xperformance tool provided by sysinternals, and that with this tool, you are able to view what is happening on the storage, on the QDEF, in the QDEF on the Windows side, the famous device parameters that we have configured with the registry key. So I just put you an example. I just voluntarily put a default value for 32 during my test. And what you can see here is that, in fact, okay, we are achieving a lot of IOs. The latency is not so bad, but because here we have configured the 32 value for the QDEF, you can see here, in fact, my QDEF is already full. So basically, we have a lot of IO that is waiting to be processed in the QDEF on the operating system. This is why the virtualization virtualization layer is not able to see what is happening from the virtualization layer perspective. Everything is okay, but from the operating system perspective, something is going wrong. Okay, so this is kind of stuff you have to be aware of. Okay, this is just some figures I put here just to show you some stuff. Okay, the performance is good with pretty well with pure storage. Okay, with a read-write ratio of 30% of write and read. The latency is not so bad because here, okay, we just have to with more the block size is bigger, more the latency for random IO is bigger as well. But okay, so we have a pretty well performance here. What is important here for the sequential read, for instance, we are reaching the 4 gigabytes of throughput. So this is something expected in your case because we have links of 32 gigabits with the fiber channel. Okay, so in this case, we can validate that. Okay, we can use all the performance the provide is able to provide, meaning all the stack between the server and the storage is able to provide the expected performance in this case. In terms of static workload, so we are using ArmorDB tool. I will not go into detail in this case. What is interesting with Pure Storage is we can integrate all the performance metric with Prometheus and Grafana reports. This is you can easily identify where the contention is located in this case. So this is an example of what we did for SQL standalone environment with a specific setup for the ArmorDB. So obviously we are using 8V CPU in this case. So yeah, we are reaching the maximum limit of what we can do with this VM, but it's expected. We will not use more than what we have in prod, but the latency is pretty good, as you can see here in terms of IO, in terms of latency. We are with a certain amount of IOPS, and from this is the yellow color here, we are data latency and log write latency are pretty good. Okay, so it is resumed here. And we also test with the final setup we have because we are using availability group. Obviously, availability group introduce additional latencies. We have an average latency of 3 milliseconds, so it's expected to have a lower transaction per minute score in this case, but the latency remain very good in terms of storage. Okay. So to resume, we managed to have enough performance setup for our workload, SQL Server workload. So just to finish, this is the end of the session. This is the key point. What you have to take care of when you design storage performance for virtualized environment and SQL Server. So the first thing is to follow the Microsoft best practice for SQL Server, VMware best practice, because all the stuff I explained you today is from the different documentation from VMware and for Pure Storage in my case. So you can follow the storage guideline at the first step. The second point is, you have to make sure you know your topology, just in case where you have some performance issue. You can identify easily where the problem is. You have to include the noisy neighborhood effect in a performance storage design because you are not alone on your virtual environment. So you have to take care about over provision, over commitment, at least for the storage size, so storage design, this kind of stuff. You can deal with pools, you can deal with shared. I didn't go into detail of that, but you have a different mechanism for VMware for that at the cost of increasing the complexity of your management, obviously. And yeah, just perform performance storage test with your context. Does not perform performance benchmark that will not be relevant for you in terms of I/O, in terms of workload. So if you have question, feel free to ask.
I will do another one. In terms of RAID technology, David, does this pure storage is running on top of any kind of topology of RAID? So are you guys basically putting the array on top of disk, so they are basically being copied or mirrored or stuff like that?
From a storage perspective, if I understand your question, we don't use any kind of replication stuff. We are using a storage replication from Pure Storage.
Okay, so natively,
yes, because it is built in by design and efficient, because you are using replication with encryption and deduplication at the same time.
Okay.
It's handled by the storage itself.
Guys, any question? David is here.
I'm sorry, a lot of concept that has introduced, but yeah, 1 hour is always a challenge.
It is what it is. Guys, any questions? You can use the chat window or you can unmute yourselves. Up to you. No, I don't see anyone basically raising their hand, so we have a shy audience. Everyone is shy.
Thanks, was nice presentation. You made my head exploding of your information.
Yeah, sure. For sure, there is a lot of content, and yeah, to ingest all this stuff is not so easy. I spend a lot of time from my side, but yeah, just to resume in 1 hour is difficult. But I try to put all the most relevant stuff for the DBA in this session.
Yeah. That was nice presentation. Thanks.
David, how long did you guys, in order for everything being aligned and tested, that was a long path, I would say, a couple of months to put everything up and running. A lot of fight with the guys from the SAN in the company.
No, because we have maybe we have a special context in my company, because we have a small team, so I'm able to do everything
Okay.
with every component of my architecture
stack.
Yeah. So, but obviously, I didn't perform all the setup. I have one colleague that is specialized on the storage side, and yeah, we work together for that.
And the decision to go to pure storage rather than, I don't know, NetApp or I don't know, AMC or stuff, or HP Enterprise or whatever, it was for some particular reason? Did you guys
of course, because we have some competitors in the game. What we okay,
what was the
I don't want to reveal a person sensitive information.
Yeah.
But from what I can say, from we have different competitors, and what we liked with performance storage is not so the performance. Pure storage is a performance storage, but you also have a lot of performance storage like IBM and so.
Yeah, what I was asking, not what to say inside information from the company, but I would say in terms of buying, because that was bought by you guys, I'm guessing, or rent, I don't know, in terms of model, but what was basically what has made you guys decided to go to pure storage rather than another vendor?
In fact,
Any specific from?
yeah, we had some some prerequisite or some
features that
some
you
key
guys...
yes some key feature for that. What we like with pure storage is it is a service oriented storage, and in my company what we wanted to achieve is to use storage as a service. This and pure storage is a strong player in on this topic. Performance is good, but you can have a lot of automation with different different framework with PowerShell, with Ansible, with Terraform, etc. And this is something that we are pretty happy with. We also like the maturity of the product, and because we also want to have, because this is you have a lot of community activity, or a lot of things, lot of emulation around this this storage, for and one thing what it was important is if we have to perform automation, or we have to manage the storage by yourself, because the one prerequisite is we don't have to be expert in the storage area to manage it. Okay, and pure storage is very strong for that. You just have to take care about volumes, and all this stuff is done automatically and managed automatically. So this is very this is what we like with the approach of pure storage.
Okay. Nice one. Thanks, man. Any more questions, guys? I have seen in here Steven Nodet basically saying a comment on the chat. What is the best practice for stuff? Oh, yes, definitely. For what we saw in the presentation.
Is the best practice versus other controllers for VMware? I would say it depends your if your workload is higher intensity workload or not. For many of use cases I see at customers, honestly, having the LSA logic is it performs pretty well. There are some, I don't remember the link, I can put it afterwards, but VMware's advise to use the parallel Power Virtual SKZ controllers if you are using more than 2000 IOPS IO per second. It is where you can have a good difference. But I will say, for me, it's always a good practice to have this kind of controller installed for SQL Server. At least you will not have to be worried about which controller, how my controller is, if my controller is performant or not. It is designed to be performant. So for all installation I did in the past, it's by default, but not mandatory.
Okay, let's wait a little bit because I have 1 or 2 persons that are writing. Let's see if I know. Okay, so Steven, just appreciate your answer.
So just to complete, you have no new adapter if you are using NVMe storage, but and it improves a lot performance compared to Power Virtual SCSI controllers, but you have to meet some prerequisites if you want to deal with it. You cannot just say, I have NVMe control, NVMe storage, and I will put the NVMe adapter for that. You have to meet a lot of prerequisites for the fabric interconnect, a lot of stuff for that. This is, by the way, why we didn't use this controller for our side, because we didn't meet the prerequisite for that.
The prerequisite, okay. Okay, David, I think I will close the session. Once again, thank you a lot for your availability, for submitting the session, and for being always present for us, because I think it is already I think it's the 5th or 6th session that you do for us.
I don't remember.
5 or 6 times that you already presented
always a
to
pleasure
us.
for
And honestly, great stuff, man. Great and deep stuff that you have showed up to us. Okay. Thanks you again for everything, and hope to see you soon presently in I don't know, a kind of let's say event, or I don't know, conference around the world. I don't know when they will start, but hope to see you soon, and to basically to drink a beer side by side with you.
Yeah, sure.
Okay.
Yeah. Thank
Take
you
care
for
of
having
yourself
me.
and your family, man, and see you soon.
See you. Bye.
Bye. Cheers.
Thank you
Big
a lot.
to everyone in the meeting. Yeah. Bye. Cheers.
Thank you. Cheers.